A Unix process is an active entity that executes a piece of code. Each process has 4 key components: a unique process ID or PID, its own memory pages, a file descriptor table, and an execution stack. These components are independent for every process. A program and a process are not the same thing. C code is compiled by GCC into machine code on disk, which is a passive file. When you run it, the OS loads it into memory and creates a process. So a program sits on disk and is passive. A process runs in memory and is active. Processes cannot access hardware directly. Instead, they use system calls to send requests to the kernel. Disk access, networking, and creating new processes all go through the kernel. Common system calls include fork, exec, wait, exit, and open. The fork system call is the basic way to create a new process. It splits the current process into 2, parent and child. Here's the interesting part. Fork returns twice. In the parent, it returns the child's PID. In the child, it returns 0. On failure, it returns -1. After fork, each process has its own address space. Changes in one don't affect the other. Even if 2 processes run the same program, their variables are independent copies. This is called re-entrancy. Files opened before fork are shared, but files opened after are not. The wait system call lets the parent wait for the child to finish. If the child exits, but the parent hasn't called wait yet, the child becomes a zombie. If the parent exits first, the child becomes an orphan and is adopted by the init process. Init, with PID 1, is a special process that cleans up orphans.